Here's integrated 3, it's problem 10-57, and it wants you to solve for x. So it has a triangle, and it says solve for x, and which methods can be used for calculating the unknown parts of the triangles. So which methods? So we're going to solve for x. I look at it and I see that this thing is a right triangle. I have bad lighting in here. It's a right triangle, and I see that if it's a right triangle, I can use my SOHCAHTOAs. So I see that I have the opposite and the adjacent sides of my triangle. So opposite and adjacent is tangent. So I said tangent of 24 equals opposite over adjacent. So opposite is 36 and adjacent was x. And then some people just get a little carried away and they just say, oh, that's going to be 32 times tangent 24. Or sorry, 36 times tangent 24. But you have to get x by itself using legitimate algebra moves. So you could either multiply both sides by x to rid yourself of that denominator, or you can use cross products. I like to use cross products. I write this as a fraction over 1, and then I say this times this equals this times this. So x times tangent of 24 equals 36, and then I solve for x by dividing both sides by tangent of 24. So that cancels this out, and then I get x is equal to 36 over tangent of 24, and then I just put that right into my calculator. And that gives me 80.86 degrees. So then letter B, here's another triangle. I don't think it's a right triangle because it's not labeled as a right triangle. I went ahead and did that thing where you go 180 minus 70 minus 23 just to make sure it's not a right triangle, because it appears to be in the book, but it's not. That's 87 degrees. If it's not a right triangle, I cannot use any trig ratios on it, like the sine, cosine, or tangent. So what do you do if you can't use your trig ratios? Well, you've got law of sines and law of cosines are your only hope. Law of sines is more simple, so I would like to try law of sines. I look at it and see if I can use law of sines. So law of sines says sine A over A equals sine B over B equals sine C over C. I notice that I have a pair. You know, I have an angle that's across from a side, and then I have another pair. So I can say sine of 23 is to 10, as sine of 70 is to x. And then I can just cross multiply. So 10 times 70 equals x times 23. 10 times 70, or sorry, 10 times sine of 70 is x times sine of 23. And then I'm going to solve it for x. So I want to divide both sides by 23, sine of 23, I mean. And that'll cancel out. And then my calculator is going to take care of all that for me. I'm just going to type into my calculator 10 times sine of 70 equals, I push equals so that I don't have to write parentheses. And then I go divided by sine of 23. And you should get something decimally, but it'll be about 20.05 units. And then here's letter C. Letter C has a triangle. I check. It doesn't appear to be a right triangle, so I'm not going to use any SOHCAHTOAs. My next favorite thing to use would be law of sines. I see there's an angle pair, but it's not really a pair because I don't have any other angles. That leaves me with my least favorite, law of cosines. So law of cosines says c squared equals a squared plus b squared minus 2ab cosine c. So I usually I look at my triangle and I figure out which of the sides has an angle across from it, the angle I'm interested in. And so this is the pair right here. So that's the ones that I call C. And if you want me to, I can label my triangle. This is angle C and side C, and then, I mean, I don't usually even label it because I just know that if that's C, then the other two are A and B. But let's see, I used 10 for A, so that means this is angle A, angle B. This is side A and side B, if that helps. If you're kind of shaky on this, it helps to label it. So anyway, I put them all in there. So this is the special side that's across from my angle, and that's the angle. The angle is the thing that we don't know. These are the other two sides. Just plug them all in where they go. And then I'm very careful with my order of operations here because people want to, I always see them when they want to add this, and you can't add this in because of the order of operations because it's multiplying against the cosine of x. So you can add these two together. So I got that. And then I subtracted that from both sides. And I got that. And then I divided both sides by negative 220. And I got, well, I ran out of room. And I came over here and I said, cosine of x equals negative 212 over negative 220. I know that that's reducible, I can see, but I'm just going to put it in my calculator anyway. So to get x by itself, you have to inverse cosine both sides. So when I inverse cosine the cosine, they go away. And when I inverse cosine this thing, my calculator just pops out this answer. Make sure you're in degree mode, not radian mode, or else your answers won't match. And that's it.